This is an update on the air pollution and community impact mapping project being done by Anna Fiallo, Alexis Frankson, and Christina Last. As you might recall from our previous presentations, we are working on a project to visualize air pollution data in Texas and make it more accessible to the public. Using Python packages, we scraped the TCEQ database for emissions data, processed the data, and created a map as a visualization. We also downloaded census data as a shapefile and processed it into a GeoJSON in order to collate with pollution information. And we then used HTML in order to create a web page that combines our visualizations with some other analytical information. Here's what the data looked like originally coming out of the TCEQ database. And here is what the landing page of our website looks like, containing our visualization as well as some other information.
As Alexis mentioned, we developed a website that includes a map visualization. Here I'll be walking through the map and its layers. First, we mapped out the TCEQ sites using their coordinate locations provided from the emissions inventory data. Here we can see the zip code region that it's located, the site name, along with the PM 2.5 emissions rate, which is in tons per year. Then we applied a heat map based on the density of sites or PM 2.5 point sources across the Texas regions. Here we note high concentration of sites in the Houston and Dallas-Fort Worth areas, which aligns most with recent EPA assessments that those regions are not meeting current air pollution standards. We then layered census data demonstrating the population density on the zip code level, where highly populated regions are shown in darker colors. When you hover over a zip code region, more information regarding the city, county, area, and population are displayed. Again, we note densely populated areas correspond with areas of high number of TCEQ entities. Another functionality of this user interface is the ability to search locations in the top right corner. For example, I can search Katy, Texas, and see where on the map it relates to TCEQ entity locations and census data.
We also built an air pollution model that predicts across space, specifically at the 15 kilometers squared level, air pollution, which is measured in parts PM 2.5, so parts per million, for the weekly average. So what you can see on the screen here is a rolling average of each week, and basically we calculate the average across a 3-month period, and then with time sliding through those specific values as we go through the year. And this is done for the year 2020, the same year that we have the TCEQ data for. So here you can see we created an analytical dashboard to dig deeper into who the key polluters are. So we can see a geospatial distribution of where key polluters are and the kind of number of PM 2.5 tons per year they're emitting. You can also see the number of sites emitting certain bands of PM 2.5 tons per year again. We can see highly divergent results with many sites producing less than 25 tons per year. But we have kind of a few, or almost 500 companies basically producing a large amount of PM 2.5 emissions. So breaking that down further, we can actually see the site names themselves and the kind of number of contributions. And the really cool thing about this is that we can then go into, for example, Texas Power LLC, and then expand out this result to see actually which zip codes are being the most affected. So 77545 being the one that has, the predominant number of PM 2.5 tons per year, over 1,000. So we can really drill down into the locations that are being most affected.
So far, we have looked at the homepage and the analysis tab. Our site also includes a tab that has the TCEQ Air Quality Monitoring Station map. This is a map that is managed by the state and shows all of the stations where active air quality monitoring is occurring. So if you click on a station, it will tell you what pollutants being monitored. and give you a link to go access that information. We also have a tab to learn more about the project. This will take you to our videos so that you can learn about our process and our motivation for this project as well. Additionally, there is a tab that will take you to the source data. So this takes you to the TCEQ website where you can download the raw source files yourself, and that's where we access those. And then last, we have a tab that will take you to the EPA website on particulate pollution. This is important because it provides more details on what particulate air pollution is and what the harmful impacts are, which can help connect a user to the data a bit more personally. So in conclusion, we think that the visualizations that we've created match what we would expect based on what has been shared by the EPA, and that they are effective representations of the air pollution in a specific community in Texas. There are some future improvements that could be made. Currently, our model contains only 2022 emissions data, but it could be expanded to contain emissions data from other years and to contain different pollutants other than just the PM 2.5. Also, the large amounts of data that we have used can make the loading time slow for some of the maps and the graphics. So future iterations of this project could use a different hosting method in order to eliminate that lag.